The following properties are true for log functions that have the same base. If you have two logs that are added together, you can combine them into one log by multiplying the two numbers. If you have two logs that are subtracted, you can combine them together by dividing. And if you have a log of a number raised to the power, you can remove the power to the outside in front of the log. The following are some examples. Log 5 plus log 4 equals log 20. Log 7 minus log 2 equals the log of 7 over 2. And log x raised to the 6th power equals 6 times the log of x. We can use these properties to combine these three logs into one log function. The first thing that you need to check is to see if all of your logs have the same base. So since we're dealing with all logs with the same base 5, we can combine them. The next thing you check for is for any coefficients. For example, 2. You can only combine logs if they all have the same coefficient. So what we need to do with this 2 is use that power rule and raise the 6 to the 2nd power. Then you're going to simplify. Log 36 plus log 3 minus log 12. Next thing we're going to do is we're going to combine log 36 and log 3. Since there's the addition, we can use the addition property and multiply the two numbers together. That's how I get the log base 5 of 108. And then the last thing we're going to do is use our subtraction property and divide 108 by 12 and get 9. So the three log functions we started with, if you combine them into one log, you get log base 5 of 9. We can also use these properties to expand the logs. So here we have log of a raised to the 4th power b to the 3rd over 2 times the square root of c. So the first thing we can do is we can separate this into 4 different logs. Log a to the 4th plus log b to the 3rd minus log 2 minus the square root of c. The reason why these two are subtracted is because they are in the denominator. Anything in the denominator is going to have a subtraction sign. Anything in the numerator is going to have an addition sign. The next thing you need to deal with is all of the exponents. 4th power, 3rd power, and c to the 1/2 is the same thing as the square root of c. So we're going to take all of those exponents and multiply the logs. So this log in expanded form is 4 log of a plus 3 log of b minus log of 2 minus 1/2 log of c. These were the following problems you were supposed to solve in the investigation. 1.04 raised to the x equals 2 and log 3 of 30 equals x. For 1.04x equals 2, we can use this power rule here to help us solve for x. So what we're going to do is we're going to take the log of both sides. And what this helps us do is isolate the x, because we can take that x, since it's an exponent inside a log, move it to the front. And then what we're going to do next is divide by the log of 1.04. The log of 1.04, that's just a constant, so we're allowed to divide by that. These two cancel out, and I'm left with x equals log of 2 divided by log of 1.04. The way you set this up in your calculator, make sure you use all of the parentheses, otherwise your calculator is going to use the wrong operations if you don't put the parentheses in the right spot. So then the final answer to this one is x equals 17.6 0.673. 3 decimal places will work here for your answer. Here's one that's a little bit more complicated, a little bit more involved. The first step is a little different. We need to isolate the exponent by adding 15 to both sides. We get 4 raised to the x minus 5 equals 87. Then we're going to use the procedure we saw before. Take the log of both sides. X minus 5, since it's the exponent, gets brought to the front. Keep it in parentheses. Then we're going to divide by log 4. Those two cancel out. Plug that into your calculator, you get 3.221. And the last step is to add by 5. So the answer to this one is x equals 8.221. The way we can solve for x when we have log functions, we can use a very similar procedure. But the first thing with this one is you're going to want to rewrite it in exponential form. If you rewrite it in exponential form, 3 raised to the x equals 30, then it's very similar to 1.04x equals 2. So we're going to do the same thing. Take the log of both sides. The x comes to the front. Divide by log 3. Final answer is 3.096. This problem is going to pull together all of the skills that we've learned so far. So the first thing we're going to do is we're going to combine these 3 logs into 1 log. So we need to use all 3 of the properties we have. First thing you're going to do is deal with this 3. That 3 becomes the exponent of x. Then you're going to use your division property. Because we have a minus sign, whenever we have a minus sign, we divide. And then the next thing we're going to use is the multiplication property, the addition property. So now that we have log of 2.4 x to the third over 6 equals 4, we can rewrite this into exponential form. Remember, whenever you have a log that doesn't have a base, you assume that the log's base is 10. So to write this in exponential form, we have 10 raised to the 4th equals 2.4x to the 3rd over 6. And now all you have to do is solve for x. 10 to the 4th is 10,000. Multiply both sides by 6 over 2.4. X to the 3rd equals 25,000. And then to get rid of x to the 3rd, we're going to take the cube root of both sides. Final answer equals 29.24. Now what I want you to do is I want you to try these problems, these 4 practice problems. Do your best that you can. I will post the answers and make sure that you show up to class ready to ask questions if you're confused. All right, I will see everybody on Tuesday.